introduce myself, usually at talks, I say that I have the great advantage of being able to come home on a good day and tell my wife that today I made 100 million websites load and execute faster. And usually she goes just like, oh hum, because she's really not into tech, and I feel kind of deflated. But anyway, so I want to start with a story. And last year was a very busy time at Wix. We were working really, really hard on adding a lot of new features and capabilities into our offerings, and in general, making what we provide to our customers a whole lot better. But unfortunately, at the same time, we also made it worse. How much worse? This much worse. This is a graph that shows the time to first contentful paint for websites hosted on the Wix platform. And I'll talk about that a little bit in a bit. But you can see, unfortunately, I'm not able to share the exact numbers, but the line at the bottom is in fact 0. So if you look, you can see that we've made the load time, the time to first contentful paint, approximately 20–25% slower due to all the code and all the functionality that we kept on adding into our offerings. So at that point in time, we realized that something had to be done. We were working on performance before that, but at that point in time, it really became a top priority across the entire company, and this is what we've been able to achieve since then. This is for desktops in the US. We measure across all the geos that we work in, and we differentiate between different types of devices. As you can see, since that time, we've been able to improve performance by almost 30%. And this is despite the fact that we continue to add more features and more capabilities into our products. In fact, if we look at what happened on mobile devices, we can see that we've been able to achieve a much more dramatic impact during that time frame, and we improved performance by up to 70–75% for first contentful paint. This was really awesome, and I'll explain in a bit how we were able to achieve that. Also, I'm happy to say that just within the past couple of days, and I added this slide while I was already here, we did the same thing for the desktops, and above that 30% improvement, we've been able to achieve another 40% improvement in relation to first contentful paint. So all in all, in terms of performance, it was a very good couple of months, which was a good thing because I happened to ask for a raise right about at that time. And it's really good to have some measurable graphs that you can actually show your boss, hey, look, this is what I did. Okay then. So when we made performance top priority for the company, we had to think about what performance means in general and what it means for us. So when thinking about performance in general, we understood that performance needs to be thought of to a great extent as a feature. First of all, customers, our customers, and certainly your own customers as well, expect high performance. Also, Google rankings are impacted now by bad performance. So for a lot of our customers, they build sites on our platform. The rank that their site gets is obviously really, really important for them. And having good performance improves, or let's put it the other way around, if their sites are slow, that would have an adverse impact on their site score. Also, there's another way of thinking about performance as a feature, and that is that, like other features, performance needs to be spec'd. Lauren kind of touched on that in talking about how product management impacts performance. So if performance is not part of your product specification, it won't happen. And even if it does happen, it won't get tested, it won't get checked. And likewise, you need to make sure that you put resources on performance, because we all know we are all always under the gun. We are rushed to provide new features, new functionality, and so forth. If management, if product, if the company doesn't allocate resources for achieving good performance, it just won't happen. Conversely, though, performance is not a feature. And it's not a feature in the sense that it's never complete. You know, you have a specification for a product, you worked on, or for a feature, you work on that feature, you have milestones, you achieve these milestones, well, then those milestones are done. With performance, it's never quite complete. Yes, you can specify certain performance goals that you want to achieve, but then, as we saw, after those come additional performance goals. And furthermore, when you're not progressing, you're regressing. Whenever we stopped investing in performance in a certain part of our offerings, we saw that they immediately started to regress in terms of performance because, you know, the developers, what can you do? They insist on adding more and more code. It's a problem. So yes, so performance is kind of like a software project. It's a journey. It's not a destination. You're constantly working to improve performance, and whenever you're not moving forward, you move backward. Okay then, so that's performance in general, but there are also some aspects that are kind of unique to us, but I think that you will see that while they make it, let's say, more challenging for us, it also means that a lot of what we did is actually also relevant for you guys, I think. So a couple of things about who is Wix. So Wix is the leading do-it-yourself website platform in the world today. We are also evolving and becoming a cloud-based development platform. We've got over 120 million registered users in 190 countries worldwide, and we get 1.5 million new users every month. By the way, since the results were published like 2 days ago, so I can say it, we've got something like 3.5 premium users, which are paying users. So we use the freemium model. A lot of our websites are actually free, but we have 3.5 million customers who are paying monthly for their website. We have over 2,000 employees. By the way, when I joined 3 years ago, it was 400. And approximately half of these are in R&D. And what's important to say about the way that we work is that every one of the developers has a key to production. I was pushing stuff into production in under 2 weeks after I joined the company. So we have a production state change every 2 minutes. That's over 200 changes every day in production. And we've got a system for running experiments and doing A/B tests. We've got over 1,000 concurrently running experiments. Just think of the number of different permutations that you can get. Obviously, you can't really check each and every one of these. So what are the challenges that we are actually facing? As you can see, the scenario is pretty extreme. So we've got tens of millions of sites and millions of domains. So most of you are thinking about optimizing performance in the context of one or maybe 2 specific domains. You know, for us, it's improving performance within several million domains. We've got a wide variety of site types running in these domains. Some of them use e-commerce. Some of them are just simple sites. Some of them manage bookings or events. They're like so many different types of sites. And also we have like 7 years of legacy sites. If somebody built a site 7 years ago and hasn't touched it at all since then, that site needs to continue to work. And more than that, I would like to make that site work faster, even though the person who built the site hasn't touched it in those 7 years. And the final thing it's really important to understand, since it's a do-it-yourself platform, it's the users who actually design the site. So we do give them templates that they use as starting points, but they can do whatever they want. So if somebody makes a site and decides to put something like 20 custom fonts on the homepage, well, they'll do that. And in fact, they do that. So we measure. We are very much a data-driven company, and we collect a ton of information and we analyze it. And in the context of performance, we use both RUM and synthetic measurements. So we measure a lot of development time, which means that when a developer builds a feature or implements a feature, it means that they're expected to use tools like the Chrome DevTools and actually measure the performance impact. And what we do in that context is that we actually do internal training of teaching the developers how to best utilize these tools and these capabilities. On the other hand of the scale, we also measure a lot in the production environment. We collect a ton of data about performance, about success rate in each and every one of our products. And it's mostly based on our own markers within the sites rather than in generic things like onload or whatever, which are rather meaningless these days. And finally, what's really interesting is that recently we added automated testing for pre-release. So we have a system in place that I hope that we'll be able to open source within the next couple of months for doing automated performance regression testing. And actually, we're not at the point where we can break the build if there's a regression, but we're certainly at a point where we can avoid deployment if there's a performance regression, and we have caught several of those, and in fact prevented deployments in those cases. So now what I'm actually going to do is I'm going to run through some of the main methods or techniques that we've used to improve performance for our users in the sites that we manage. Now, a couple of things. Obviously, I'm going to show for each one of these features the improvement that it did for us. Obviously, your mileage will vary. It very much depends on your types of scenarios, but it will give you sort of a starting point, at least, or a way to kind of gauge what's more potentially useful for you or what isn't. Many of these points are worth an entire talk of their own, so this is obviously going to be very much the tip of the iceberg. And finally, you might notice that the percentages accumulate to more than 100. That doesn't mean that we have negative loading time. Obviously, if you reduce your load time by 10% every month, you'll never actually get to 0. And like I said, we also unfortunately keep regressing. So these are the improvements, but also regressions do occur. So first of all, we made a change in the organizational level, in the way that we think about and we work with performance. So first of all, as I mentioned, performance was declared as a top priority company-wide. That means that the CEO actually addressed the entire company and told everybody about like 3 top priorities items for the company going into the upcoming year, and one of them was performance. For myself, I'm like in charge of the front-end performance and the technical aspect of that, and I literally engage with somebody from senior management almost every day about where we are and what we're doing and what we hope to achieve. We've allocated significant resources. Like I mentioned, if you don't allocate resources, it's just not going to happen. So we did performance reviews for all the projects, and we try to do it as a sort of a regular thing. It doesn't happen as often as I would like, but we do try to do it every couple of months at least. We have dedicated performance teams. I'll mention some of those in a bit. And we've also tried to instill performance leaders in various key projects at least. Those are developers that are interested in performance and wanted to learn and wanted to invest effort in that. And finally, as I mentioned, we do consider performance regressions as blocker bugs. So if, for example, we do see a performance regression in a version pre-release, we won't release that version until we actually fix that performance regression. So server-side rendering, you saw those big drops that I showed you for mobile and then later for the desktop. Those were thanks to server-side rendering. We use React, sometimes with Redux, sometimes with Mobix. When we chose React, one of the reasons that we chose it was because it has the capability of doing server-side rendering. But it actually took us a long time and required a lot of effort because a lot of the code was unfortunately not written with server-side rendering in mind. So what did server-side rendering give to us? Why is it so much better? Why did it provide us such a great improvement? Well, server-side rendering is good because, first of all, servers are faster than weaker clients. That's why we saw around up to 70% improvement for mobile devices and about 40% improvement for desktops. Servers are pre-hot. We actually download a lot more JavaScript code than I would like in order to get the site first visible and then fully interactive. And all that JavaScript code needs to be downloaded, unzipped, parsed, compiled or interpreted, and run the initialization. All this takes a fairly long time. In fact, we got to the point where approximately like over half the time until the first visibility was actually as a result of just downloading and initializing all the JavaScript code. So in the server-side rendering, we're actually able to use pre-hot code. So we have the code loaded inside the server does one session, and when it's done with that, it can actually run the next session using those already loaded libraries. So that means that you save all this time. Also, obviously, it's faster data fetch. For us, for example, all the site definitions are stored in JSON files. From the client-side perspective, these needed to be downloaded using AJAX. On the server, it's just reaching out across, to a server that's right along that server. But as I mentioned, implementing SSR was actually fairly challenging. So it can be hard to implement. How hard to implement? We invested several man-years in implementing SSR for our platform. It might have been easier had it been one of the tasks from the get-go and not something that we implemented on top of an existing platform, but that's the way it is. Also, obviously, servers cost money. We transitioned from a situation in which we were primarily using our servers for storage and for network to a situation where we were also paying a lot of money for CPUs. And we, in fact, pay tens of thousands of dollars every month for the CPUs that we use for server-side rendering. And last but not least, while server-side rendering does improve time to first contentful paint or first meaningful paint, it actually can delay the time to full interactivity. Because if you're thinking about the React scenario, you send down the HTML then becomes visible, but then you need to download all the JavaScript because you also need to do the rendering on the client side in order to make it fully interactive. And then the JavaScript download resources compete with other resources that you're downloading, like media and whatnot, and as a result, the time to fully interactive can actually grow, and in fact, for us, has grown. So all in all, the performance improvement from SSR, depending on the scenario, varied between around 35 to 75%. Caching. I'm sometimes shocked by how many times I encounter scenarios where proper cache headers are simply not defined for a resource. You know, we talked about progressive web apps, and I'm trying to remember who said that, but before you think about using a service worker to optimize the way that you're downloading resources, make sure that your cache headers are properly specified. I can't say how many times I've seen resources that are downloaded again and again and again, even though they never change, just because they don't have the appropriate cache header. What we've done, by the way, is for most of our resources, we put either a version or a hash in the URL, and the original HTML file actually contains a map to the version that we're currently using. So this means that whenever we change a version, it's not the same file that's changing, you actually get a new URL, which means that we can specify really long cache durations, ideally infinite cache durations, for our resources. I think currently we specify around 1 year, for example, for the JavaScript resources that we download. You can use libraries from common public CDNs. For us, that's less of a factor because we have our own CDN domain, but it can be really, really have a significant benefit. If, for example, you're using Lodash or you're using React, then you can download that from a common CDN because it's likely to be used by other websites as well. Using e-tags, I won't go into that too much. And obviously, avoid cache busters. Again, something that often surprises me is how many times I see people putting cache busters in their URLs for, I don't know, various reasons during the development process, and then they just stick there forever, and then regardless of the cache headers, nothing's actually cached. Bundling. But I think Paul Irish recently tweeted that despite everything else, bundling is still critical for achieving good performance in the modern web. And why is bundling, and by bundling I mean taking several smaller JavaScript files and combining them into a single JavaScript file. Sometimes you can add additional resources like CSS and whatnot. So why is bundling so good? Well, first of all, translates to smaller downloads. If you're going to compress one large file, it's going to compress a whole lot better than 10 smaller files. It also means less of an overhead because you get fewer HTTP headers, and you also avoid blocking due to resource download orders. Suppose you have an AJS and a BJS. A is dependent on B. You download them separately. A happens to finish downloading before B, well, now you actually have to wait for B to finish. Whereas if they're bundled together, then obviously they arrive together at the same time. But on the other hand, it also turns out that sometimes it's actually beneficial to unbundle. And I have seen scenarios where things have been over-bundled, like building one huge 1 meg JavaScript download, and you think, hey, this is minified and gzipped, and it's still 1 meg. Well, that's a whole lot of JavaScript in there. And why is it such a good thing can be such a good thing to unbundle? I mentioned that it can you can get a better use of CDNs. For example, if instead of bundling Lodash is an external resource, you can get it from a common CDN. Good chance that it'll be already cached within the browser, and you save the download for downloading those bits. You get fewer cache busts. When you bundle everything together, then every change you make in your code is going to force the download of the entire bundle. Whereas if you break it down, you only download those bundles that actually have changed. And you don't download, and there's a lower likelihood of downloading unneeded code. And you also get the benefit of parallelization, where you're actually able to download stuff while you're parsing and executing other stuff. Now, thankfully, it's actually possible these days to get like the benefit of both. If you're using modern tooling, like for example with Webpack, you have tools that you can use for doing things like code splitting and kind of get the advantages of both bundling and unbundling. For us, by optimizing the way in which we bundled and unbundled stuff, we were able to achieve between 5 to 25% performance improvement, depending on the network scenario. Use HTTP2. We're going to hear a talk about Quick. It's going to be, for me at least, it's going to be very, very interesting. We're also looking at starting to use that, but we are already using HTTP2. The benefits of HTTP2, you get compression of HTTP headers. You get HTTP2 server push, which we don't actually use. I can tell you later why. Pipelining and multiplexing of multiple requests. You know, it used to be that like 6 concurrent downloads was the magic number. You wanted to have 6 resources for each domain because the browsers would actually open 6 sockets to each one of those domains, and you could do 6 concurrent downloads on each. Well, with HTTP2, you can get, well, as many concurrent downloads as you want. Realistically, though, you want so we've grown from around 6, let's say, resources per domain, which was the ideal value before HTTP2, to up to 50. 50 is a bit on the high side. We try to keep it to between 30 and 40. And how do I know the benefit that we got? Well, funnily enough, what happened was that due to a system problem, we actually turned off HTTP2 for a couple of hours, and during that time, all our graphs showed 10 to 20% performance degradation. Now, your mileage will definitely vary based on the networks that your users have and how many resources you're downloading, but that was the situation for us. Resource hints, those were mentioned before, they're really awesome. They're great. I love them. They're so beneficial. Basically, put a link tag in your HTML or put the link colon in the HTTP header. I won't go into them. This is worth a talk in and on its own. We use preload, we use prefetch, we use preconnect. I don't think we currently use DNS prefetch, but we might. Our scenario is slightly different than yours. We sometimes don't, so for example, I know that I would need to download certain resources from a domain, but I don't know which resources I'm going to be downloading because it's a site that a user built rather than a site that we built. So it's a more of a generic scenario. So pre-connect or DNS prefetch can really come in handy in those scenarios. Using resource hints gave us up to about 10% performance improvement for first contentful paint. Progressive render is a cool technique that we implemented recently. Basically, it means that in the first pass, we just render the content that's within the viewport. That means, you know, the term above the fold. And then the rest, we render progressively during idle time. So you do use something like request idle time, or you do it immediately when the user scrolls down so that they don't see blank space. And it also ends up in prioritizing the resource downloads, because if you don't render an actual image, then the image doesn't actually start downloading. So as a side effect, it meant that images that were above the fold actually started downloading before images that were below the fold. Using this technique, we were able to achieve between 5 to 10% performance improvement. But what's really interesting is that some really heavy sites, we saw improvements of up to 50%. And we have seen sites, users have built sites, where you can literally scroll for 20 pages before you hit the bottom of their homepage. Why? Because they want to have everything within that initial homepage. We also obviously do a lot of profiling and code optimizations, which basically just means, you know, it was mentioned, all that boring stuff of sitting down with a team, with the, let's say, Chrome DevTools open, and just basically going through the code, identifying hot code, optimizing that code, maybe changing algorithms. DOps is probably also worth an entire session on its own, what they are and how to avoid them. But what I can say is that by doing that, we've been able to achieve around 10 to 20% performance improvement in our code, just by going through the code and making it more efficient. Coming soon, I can't give a number for that yet, but unfortunately, the current situation for us is that at least some of our layout is actually done using JavaScript. We have some really fancy layouting going on due to the way in which our site builder works. And when it was built several years ago, CSS was just not up to par in terms of what we needed to achieve. Well, now, thankfully, thanks to Grid, it is. So we are in the process of transitioning from also using JavaScript for layouting to just using CSS with Grid, and the initial results look really promising. In this context, I want to mention an open source library that we've recently introduced called Stylable. It's a way to style components. It's like bringing componentization into CSS. It's really cool tech. We're using it for what we're doing. And like I said, it's open source. And if it seems interesting to you, please talk to Bruce and also check what this links to. I think you'll find it interesting. So to summarize, you know, it's true for us, and I guess it's probably true for you. Our customers and your customers have alternatives. You know, website builders, off the top of my head, I can list around like 8. So we're definitely not the only ones. And we always realize that and think about the fact that our customers have alternatives. So if we want to retain those customers, if we want to keep these customers, if we want to get more customers, we have to, our management and we ourselves need to demand performance from ourselves because our customers are demanding it from us. And like I mentioned, we need to make it sure that performance is part of our specifications. We measure performance all over, and we constantly fine-tune the way that we do these measurements. And last but not least, we allocate resources to ensure that all these tasks actually get done. So that more or less concludes what I wanted to cover. So thank you all very much. And if you have any questions about Wix or about how we do performance at Wix or any one of these points that I've mentioned, do feel free to grab me after this talk, during lunch, whenever, and I'll be happy to discuss it with you. Thank you very much.